But today we are estimating the co-integration relationship. We are applying the co-integration test using Gretl. In Gretl, open the same file that I had shared with you people, the time series.xls. We have four series: LM3, proxy of money supply, IIP, LIIP, log of IIP, index of industrial corruption of India, log of call money rate, and log of exchange rate. Now, what I will be doing, first of all, obviously, you have to see what is the order of integration for all these four series that I'm going to use to model the co-integration relationships. And it is noticed that all the four series are I1, though for LCMR and LER, ADF was not confirming the existence of unit root, but KPSS test was confirming the existence of unit root in these two series. So I told you go by different tests. If some tests are confirming the existence of unit root, KPSS is a very powerful test, even more powerful than ADF test. So it is better to go ahead with the decision that call money rate and LE are also stationary of order 1, integrated of order 1. So all the four series are integrated of order 1, so Johansen co-integration is applicable. Now, before applying Johansen co-integration means to see whether there exists some long-run relationship or not, we have to see what should be the optimum lag length for this co-integration vector or co-integration model. So what you have to do, go to model, okay, multivariate time series, bar lag selection. So bar lag selection criteria means you have to select the endogenous variables, like we have four endogenous variates. When four endogenous variates are there, we can take out means with these four endogenous variates, we can see whether what is the optimum lag length. Include a constant, you can include seasonal dummies, you can include trend in VAR. That is up to you, means what type of model you want to estimate. Right now I am including the constant and as well as seasonal dummies. Click OK. Maximum lag length is 24, means for 24 lag lengths it will compute the different AIC, SBC and BIC. Sorry, AIC is the Ekeken information criterion, BIC is Bayesian information criterion, and HQ is the HQC is the Hancock criterion. So for 24 lag lengths, 24 values of each information criterion will be computed, and wherever they are minimum, that will be chosen as optimum lag length. You can see that AIC in the column AIC, it means the column of Ekeken information criterion. This asterisk has been applied by the Gretl with 4 lag lengths. BIC suggesting 1 lag length, and Hancock criterion is suggesting 2 lag lengths. So better to go by 4 because maximum lag length suggested is 4. So let us go by a 4 lag length. Means the lag length of 4. So if I go, so optimum lag length of 4 has been selected. Go to model, multivariate time series, co-integration test, Johansen, okay. LM3, LIIP, LCMR, LER I have selected as 4. See, from here you have to ultimately select. I told you earlier that whatever dependent you want to take in the co-integration modeling, take that dependent as first endogenous, like LM3 I have selected first, then LIIP, LCMR and LER. I am choosing these 4 endogenous. Detail of regressions, you can include some seasonal dummies if you want to include. In unit root testing, I didn't include any seasonal dummies. So, did I include the seasonal dummies or not when I applied this VAR lag selection criteria? I think we had used, trend we didn't use. We used seasonal dummies. So let us click include seasonal dummies because we were using this also. Unrestricted constant. There are no constant model, means origin stationary, means your co-integration is around origin. Restricted constant, unrestricted constant, restricted trend, unrestricted trend. Unrestricted constant is the most frequent model applied in econometric research. So this model is being selected by default. Unrestricted constant we had chosen the constant in var model selection criteria, so that's why I'm using this unrestricted constant here. The constant is coming here, seasonal dummies are coming here, and optimum lag length we had chosen was 4. So I will be giving 4 here with 4 lag length and these seasonal dummies and constant. I'm going to run this co-integration test. So these are the co-integration statistics. You can see rank 0, 1, 2, 3. These are the ranks of pi, the pi matrix I told you earlier. Then we have eigenvalues of for each rank of matrix. We have trace statistics computed for each rank. We have lambda max test computed for each rank. And obviously, I had given you in that paper the two statistics, trace test and lambda max test. Both tests are available. You can see their p-values also. If we observe these p-values, we can say that first of all, let us go whether there is zero, means the null hypothesis is zero rank. So zero rank null hypothesis is rejected. Okay, you can see this p-value less than level of significance. I told you trace is more powerful than lambda max, so trace is rejected. Okay, though lambda max is also rejected, but it is rejected at 10% level, not at the 5% level. But issue is trace is rejected at strongly at even 1% level. So we can go ahead with level. So we can reject the hypothesis that there is no long run relationship. So zero rank means there is no long run relationship, that has been rejected. Next is there exists one co-integration vector, that is a uniform relationship. Means the four variables can be represented by a single equation to represent some long run relationship, and we can see that this null hypothesis is rejected 0.01, means that 5% obviously this hypothesis is rejected. If we go by lambda max test, even this hypothesis is also rejected. 0.02 is the value, less than 0.05. So hypothesis of one co-integration vector is also rejected, means we can't represent the four variables relationship with one single regression equation, time series equation. Ultimately, let us see whether 2 rank is there or not. So for 2 rank, we can say that null cannot be rejected if we go by trace as well as lambda max. P-value is greater than level of significance. See, 0.2775 is much above 0.05. 0.4003 is much above 0.05. So this null hypothesis of 2 rank cannot be rejected. It means there are we need two equations to represent ultimately the long run relationship between among these four variables. Okay, we have to prepare a model in such a manner that we can represent the relationship with the help of two vectors. So ultimately 2 is the rank of co-integration, right? These are the beta matrix, alpha matrix, then normalized beta vector and the normalized alpha vector. Normalized one is dependent on IIP, and these are the effects. But the p-value sets are not available for each effect. So I will be, since it has been finalized that there exist two co-integration vectors. Okay, model is clear, lag length is clear. Now let us take out these vectors by running vector error correction mechanism. Okay, Johansen test is clear to all of you people. Since two co-integration vectors have been confirmed by Johansen test, means there are two statistics, trace and lambda max. Most tests are confirming the existence of two vectors. Now let us go to model, multivariate time series, and VECM. Okay, in VECM, what we'll be doing? We will be selecting the lag length is 4, the rank was 2. Okay, endogenous variables are there. If regression detail is required, we can do include seasonal dummies. They have already been included. Unrestricted constant, that has already been included. So final model. Okay, click OK. So these are the coefficients of var and differences. Okay, coefficients, equations in lag levels. var system in first difference system with levels. See, I'm not going by above statistics. Let me show you the beta co-integration vectors. These are the co-integration vectors. The first vector is lm3 as dependent variable, means lm3 is having a coefficient 1 because it is a dependent variable in first equation. The second is LCMR, LER, and if we take out the other equation, IIP is the dependent, CMR and LER. So ultimately, by default, what it is doing, it is by default it is making two equations. It is making two equations, LM3 as a function of rate of interest, CMR, and LER. Okay, and LIIP as a function of LCMR, LER. Okay, is it okay? See, sometimes we don't agree that we don't want, this type of estimation. Anyhow, that I will tell you later on. And these are the impacts of LCMR. Obviously, if it is a positive coefficient, you interpret it as a negative effect. Okay, because we will take IIP and LCMR to the right hand side, and LM3 will be at left hand side, then sign will change. See, in bracket standard errors are given. Coefficient divided by standard error can give you the T statistics or Z statistics for a large sample. You can compare that Z with the 1.96 to see whether the impact is statistically significant or not. Anyhow, so this is giving me two equations, LM3 as a function of CMR ER and LIIP as function of CMR and ER. It means it says your four variables can have two types of relationship by default. By default, it is doing what it is doing. If it is a vector like beta 1 1, beta 1 2, beta 1 3, first row, second column, first row, third column, and first row beta 1 4. 1 4 is the first row, fourth column. Okay, and let me tell you, first row means first co-integration vector. Beta 2 1, beta 2 2, beta 2 3, beta 2 4. Okay, if we write this matrix of 2 rows and 4 columns, okay, what it is showing, beta 1 2 is equal to 0 by default. Okay, and beta 1 1 is 1 by default. If we go to beta 2 1, this is equal to 0 by default, and beta 2 2 is equal to 1 by default. Can you see this or not? Too much of?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, if I am taking it first column of co-integration vector as first row, इसको रो मैट्रिक्स में कन्वर्ट करते हैं. So if I take it as first row, then beta 1 1 is equal to unity, beta 1 2 is equal to 0, and on the other hand, beta 2 1 is equal to 0, beta 2 2 is equal to 1. Now, what I want, I don't need these equations like LN3 as a function of call money rate and exchange rate, LIIP as a function of call money rate and exchange rate. I go by economic theory. My economic theory says that LM3, if it is taken as an indicator of demand for money, it must be the function of output, that is LIIP, and rate of interest, that is LCMR. Okay, so I write LM3 as a function of LCMR and LIIP, or LIIP and IIP is my second variable, LCMR, yes. So LM3 is the function of LIIP and LCMR. IIP is a classical effect, and LM3 is function of LCMR is the Keynesian effect. And further, I can say that my L what is more dependent upon exchange rate? Tell me. If we go by Fleming-Mundell model, tell me, have you seen the 4-panel diagram of Fleming-Mendel model? Okay, have you seen the open economy models or not? सबने पढ़े हैं आप लोगों ने? In your macroeconomic modeling, we had IS, LM, and BP curves in which we had two axes, rate of interest and income. Okay, income was modeled on a 45-degree line, and then it is becoming net export line. Net export line may we had two axes in current account, that was income and exchange rate. In foreign flow curve, we had exchange rate and interest rate. So we can say that your exchange rate LER probably or LIIP output can also be taken as a function of LER and LCMR, because if rate of interest will change, then ultimately output will be factored, and if exchange rate will be changing, then even IIP will be affected because of change in the demand, aggregate demand in the economy. So I don't want LM3 as a function of CMR ER, LIIP as a function of CMR ER that has been given by default. But I want two co-integration relationship in which LM3 is represented as function of IIP and CMR, the second and third variable. Okay, and LIIP is taken as a function of LCMR and LER. Right? What to do? Linear restrictions. We have multivariate time series, VCM. Do we have an option of restrictions here? No. We don't have. I think we can apply the restrictions. Yeah. See here, if we go apply the linear restriction, for example, B21 denotes the first element in the second co-integration vector. Okay, what we have to do, we have to apply these restrictions like B. We can open up the help if you want. Okay, B. We need four restrictions ultimately. Four restrictions with which variables will appear as dependent variable, like B1, 1 is equal to unity. This first restriction I want. Okay, because LM3 I want to be the dependent variable in first equation. In first co-integration vector, I want IIP and CMR to appear, so my exchange rate must be 0 in first equation. So 1, 4. Okay, in my co-integration vector, first cointegration vector, fourth coefficient must be 0. Then next is B, second cointegration vector. I want to model IIP as a function of CMR ER. So 2 must be unity. Okay, and B, obviously 2 1 has to be absent from my equation. So 2 1 is equal to 0. These 4 restrictions I will have to apply. Test of restrictions is clear to all of you or not? How I have used these restrictions. See, this is the default model, but I don't want this default model, because in this default model, LM3 is modeled as a function of LLCMR and LER, and LIAP is modeled as function of interest rate and exchange rate, CMR and ER. Okay, what I want is LM3 to be the function of IIP and CMR, not of ER. Okay, LM3 as a function of IIP and CMR, and IIP as a function of CMR and LER. So what I will have to do, LM3 as a function of IIP CMR means LM3 will be dependent. So the variable which is dependent, that coefficient must be unity, while the coefficient which you don't want in the equation must be 0. So B11 has to be unity. So LER I don't want into first equation. It means it must be 0. So beta 1 4 has been put is equal to 0. Similarly, in second equation is okay, but I will have to put the restrictions like LM3, that is beta 2 1 is equal to 0 and beta 2 2 is equal to unity, because IIP has to appear as a dependent variable. Click OK. Beta 2 1 is equal to 0. It's showing an error. Beta 1 1 beta 2 1 is equal to 0.
Sir, I think you've put 2 commas
Yes,
in beta 1 4.
beta 2 1 is equal to 0, beta 2 2 is equal to unity. Yeah. Click OK. I had put the 2 square brackets. Click OK. Now this is the test of restrictions. Okay. The model is fully identified. So test of restrictions is valid. With these test of restriction, model is fully identified. Strong convergence is observed. We can observe that these are the new coefficients. These are the new coefficients. You can see. Okay. And in these new coefficients, I told you, if it is negative coefficient, you have to interpret it as a positive effect, because when we'll take the coefficient to the right hand side, then obviously sign will change. So this is appearing as LM3 as a positive function of output, IIP. Okay, as IIP will change, class so what we have done, we have computed the new values of a beta vector, and these values are better than other means those equations which we don't want. So ultimately we can say that output is positively affecting LM3, and this is the, if your coefficients are in logarithmic, then this is the output elasticity of demand for money, and this is the interest elasticity of demand for money. And interest elasticity, you can observe, is negative. As rate of interest rises, demand for money is falling. This is the unitary mode less elastic, this is unitary mode elastic. See, coefficients ultimately you have to see, because I have taken in my file there is a log of IIP, but generally we never take the log of an index. Okay, so coefficients can be worked out again. The second equation, in which IIP is dependent upon CMR and ER, you can see huge coefficients have been observed, again there is some problem of maybe of multicollinearity. Yeah, that's why these coefficients are very high. Okay, they can be, I can we can see what is real problem with this equation. But ultimately, this is the method how we can work out the Johnson co-integration relationships. If two relations are there, how to apply the restrictions. Even you may have in four variables, you may have three equations maximum. Okay, you may have even single rank, means if r is equal to 1 and null can be rejected, then with single equation you can represent the entire model. In that case, there is no need of any restriction. Okay, so that was all about today. Tomorrow we will be taking further advancements in Johnson co-integration test. Thank you so much for the day. I will be meeting tomorrow. Now I will be taking your attendance.